Hey, welcome to this video about local development clusters for Kubernetes. In particular, I want to talk through why I've built my own Raspberry Pi based cluster and why it's really challenging from the long-term perspective to have one of these clusters remotely and how much you end up spending, and also some of the limitations around that, right? I spend my time building operators, working with resilience, failover at the cluster level, and so I need to unplug things and I need to be able to test things very quickly to iterate on code changes. I think a lot of us can get that kind of feeling that when sometimes we're using these cloud providers, there's a kind of an overhead in having to deploy out your OCI and then see it update, or unplugging a node isn't as simple as just pulling an Ethernet cable out. So today I want to talk you through my local setup, and maybe you'll draw some inspiration, maybe you'll see some things that you want to challenge, but let's jump right into that without any further ado. So typically speaking, I use Raspberry Pis because they're ARM64, they're cheap, and I can put the actual cluster for K8s in a bunch of different ways. So whether I want to build a single control plane node or have a 3 control plane node with several workers, it doesn't matter. I can set that up and it's relatively inexpensive. Now, the key problem with Raspberry Pis is just that they're hard to get, but they do come up even on Amazon at normal list price. It's just you got to keep a tab on that on your wish list. I picked one up the other day, these 4B 8 gigs, and it was I think $70 on Amazon. So the kind of normal list pricing, and that lets you build your cluster out in lots of interesting ways. So the way that I actually set these up is I typically would buy a PoE hat, put that on top of the Raspberry Pi through the GPIO pins, plug that in on top just so that I don't have to deal with an external voltage rail, and then I put an attached SSD, and that would be using a SATA to USB converter. So you could argue you don't get top speed here, but it's decent enough for local development. Now, in terms of the actual software that goes on top of this, we have Ubuntu 22.4, so Jammy Jellyfish, with Mikrotik. Now, I'm biased towards Mikrotik, but you could use whatever Kubernetes you want. The reason I love using Mikrotik, apart from being heavily involved in the development of that product, is that I can switch K8s versions very easily. And I mentioned working with operators, you need to test against different versions. So I can go from a 121 K8s right up to a 124 by just saying snap refresh Mikrotik and changing the channel name. On top of that, I also use Tailscale heavily. There are a bunch of folks who are giving you solutions for like how do you do local development and access it through the net. It's really, really easy. I'm going to talk you through sort of how I do this. So I typically install Tailscale. I put the agents running on each one of these nodes, and then I will add that to my Mac. Now, the trick here, the secret sauce, is that you can't actually access this outside of your network, right? Because you will have a differing IP address to the one that the cluster was provisioned with. So what you can actually do with Mikrotik is you can change that inside the config. So I'm just going to show you really quickly. So first things first is I'm just going to grab the Tailscale address of my Raspberry Pi. Now, what you can also do is you can persist these on the local router, and I'll come back to talk about that a bit more in a minute. But what I've done is I've just grabbed the IP address that I've set up on Raspberry 0, and I've accessed that through my Tailscale CLI on my local Mac. Now, what's interesting is that with Mikrotik, you can actually start to look at where and what do you want to add as external IP addresses so that you can have access to this inside of and outside of your home network. And that's really exciting because I can go to a cafe and I can access my kube config as long as I have my Tailscale CLI running on my Mac. So let's just go ahead and find that. I'm going to test my memory here and just see if I can find the CSR. Right, here we are. So you'll see inside of var snap Mikrotik current, we have what is called the CSR conf template and the CSR conf. The conf template, you'll see what's interesting about this is that you can add alternative names. And I mentioned adding your Tailscale IP address. You've got a couple of choices. You can either add it here in this range of IP1, IP2, IP3, etc., or you can add the local router name and have a Tailscale agent on the router. I mentioned I come back to that whole idea of routers and networking, what's going on. So if you look here, typically a home network only has a single tier of network. So you'll get an ISP router that you get mailed through your letterbox, and it'll have like a 192.168.1, and that's a /24 network. What I've done is on this stack, as I've set up a secondary Mikrotik hex PoE router. Now the reason I've done that is so that I can set persistent DHCP IP address on the IPAM management, set persistent IP addresses up so that these always have the same IP addresses. The reason that's important, and the reason that I don't just rely on that Tailscale IP address alone, is because when they talk to each other, these need to know where they are, right? And they use the IP addresses on the local network to do that. And so therefore having that persistent IP makes things a lot easier. You can do some magic with the host names, but still setting the persistent IP addresses based off the MAC address of the individual unit is a really nice strategy for this. So I've got a Mikrotik inside my cluster, and actually we should draw this out like that. And then I also have the actual units, the Raspberry Pis themselves underneath this. This Mikrotik hex PoE is a managed switch, which means it speaks routerOS. routerOS is an operating system, a slimmed down sort of Linux-based operating system. Mikrotiks use them heavily. Mikrotik is a company from East Europe that I really, really like, and dealing with Mikrotiks is really easy to do so. And in fact, you can actually telnet into that Mikrotik router and make changes as you want it. So for example, if we go to telnet, now I believe the router is on 106. In fact, I'm on my Mac here, so let me just jump onto my Raspberry Pi, which is just here. I'll just do it in another bigger tab so you can see it. Okay, so let's just log in. Okay, so we go telnet. Now we can open a connection. So 192.168.88.1. So from this inner network here, the Mikrotik is the gateway, whereas from the outer network, it is just a device. So the outer network, the actual IP address is 106, right? And you may have seen, if you were quick, that this IP address has also been added to the kubeconfig as an alternative IP address listing. So within the certificate, as it gets generated, you can connect from that router directly. That's kind of important because what you can also do with the Mikrotik is you can set up forwarding rules. So one of the forwarding rules I have is that any traffic from the ISP router that has the 6443, I think it might be 68443, which is the Kubernetes API server port, will get forwarded through the Mikrotik to the control plane node directly. So let's just log in. I might be testing my memory here. I can't remember if Mikrotiks have a default password on them. I think mine does. Let me just try. Oh yeah, here we are, we're in. So this is the routerOS telnet interface, and you can do a bunch of stuff. I mean, the most useful stuff that you'll probably find that you end up doing a lot is either going to be in firewall, or like I've done, it would be through NATing. So you can also set up configuration around NATing and around the DHCP side of stuff. So let's just go into address. And what's really useful here is I can start to look at things. I can do a bunch of stuff around printing out addresses that are currently leased out, etc. There's also a really good web UI for this, which is probably easier to use. I'm not going to show you that today because that would mean I have to reverse proxy from a node back to my local computer because it's on the inner network and I haven't exposed it outside, but that's effectively how it works. So I'm just going to jump out of this. I'm always terrible with the exit commands on things. I just end up closing the window completely. So we have our cluster network, right? We've got the Mikrotik sat here on our /24. All of our nodes are running and they're all networked together. But how do you actually manage this stuff long term? Well, for me, it's a simple solution, right? I don't try and overcook this. So I just use Ansible. So I think I call it something like, let's have a look. Let's jump up. Ansible Mikrotik. Right, it's a super simple Ansible implementation. I don't even have a playbook. I'm just using Ansible directly, not Ansible playbook. So from my laptop, which is on this network here, and I'll just add that in so things are a little bit simpler. There we go. From my laptop, I've just hard-coded the IP addresses of my Tailscale IPs for these, and the laptop actually communicates through Tailscale back down to the cluster, right? So it's like this. So what you can see is if you go into the inventory, these are all my Tailscale IP addresses, and that means I can use Tailscale VPN to resolve and connect to these. So you'll see in my README, just to remind myself half the time, I do some simple commands like, get the temperature of my Mikrotik's my Raspberry Pi nodes, and then I can get what's running with Mikrotik as as well. And you can see there we go. So we can do something like snap info Mikrotik, and that should give me the Mikrotik information. I told you as well, Mikrotik is pretty rock and roll because you can switch between any version of Kubernetes pretty dynamically. It also tells me what's running on Mikrotik, right? So flannel D is inactive because I don't use flannel. I'm using Calico, and it tells you a bunch of other information. This is a super simple implementation, right? But it works for me. I also mentioned that idea about your remote kubeconfig. So if you look at my kubeconfigs, I have this thing called remote. That is the Tailscale IP address of the control plane. Okay? So if you add that IP address in, or rather, if you add in any IP addresses you'll be connecting through to the control plane, then you will be absolutely fine for when you connect via certificate. You won't get an X509 certificate error. So if we then connect through this, we can see that my cluster is up and running. And I've got its heavy utilization. I really, by the way, this is an interesting thing. So the critical memory level, it's sort of a misnomer. The kubestate metrics is pretty simplistic in the way that it evaluates memory thresholds. But needless to say, I've got a whole bunch of stuff running on here. What I also want to show you is something really, really cool that you can do that I think is pretty unique to Mikrotik in terms of it being out of the box. So I have a bunch of stuff running, right? I've got Portainer. Let's take Portainer for example. Now Portainer, let's put that on this diagram here. Let's say I have Portainer running on top of Mikrotik, okay? Really simple application workload. What I can also do is a Mikrotik enable MetalLB. MetalLB is a load balancer that binds to the host ports on that node. Now, when you combine MetalLB, so host node port binding, with Tailscale, what it will do is it will search and see that that port is open. So if I then go to my Tailscale services, Portainer becomes accessible anywhere in the world across my Tailscale VPN, which I think is really cool. In fact, there's a couple of different ports open, so I've got to find the right one. We'll do it. Is it this one? There's a couple of them, so I'll just check. Okay, so we're getting close. Let's go services. I actually just got to check which port it uses. So HTTP should be 9000. Let's try that. There we go. So I've accessed the Portainer UI, which is super awesome. And you can do the same for anything that goes through the load balancer. And I apologize, I did say node port, but it's actually when you set it to load balancer, that is when MetalLB provisions an IP address. So the way MetalLB does that is you tell MetalLB that you have a pool of IP addresses, right? So in my case, I gave it from say 50 to 65, and then MetalLB effectively does the IPAM for that range, and it then assigns those IP addresses. So anything that has a load balancer, it is possible for me to access through the Tailscale service. And you can see also the MetalLB speakers are on here because they also have unique ports. They have an interface as well. You can see here 53, so we've got DNS resolution on here, as well as other system services on the Raspberry Pi nodes. That's really interesting to me because this now gives me this new dimension of, okay, well I can actually spin up a service and treat it as if it was on the web, and yet I have my local development environment. This has been really useful to me when I've been developing FlagD under the operator, the open feature operator. FlagD is a system for controlling feature flags, and here is the operator that runs FlagD inside of it. And it's been really nice because if I want to, I can expose metrics. I mean, just to go a step further, metrics are also exposed. You see I've got kubepromstack enabled here. By default, if we go to node exporter, so again, cluster IP, which isn't actually exposed in cluster as an external IP, but it does have an IP address, it does have a port on the node that it's exposed to scrape from. you can see that it shows up here. So if I go to any one of these on 9100, absolutely by default, I now get the metrics out of Node Exporter over the internet for any of these nodes, which means I can actually set remote monitoring up. You can also use a remote cluster with Tailscale underneath the interface or connected to the interface with Grafana to access cluster metrics across the web. In my case, though, what I can do that's also super easy is I just go to Grafana, and you can see that I've already got a load balancer defined for Grafana, and I'm just in the process of setting that up. I don't think I expose it yet, but I shall. I mean, in the meantime, we can just do a local port forward and just make sure that that all works. So you can see this is a pretty quick to use development environment. I've got effectively realistic observability. I'm using a full-scale observability system. Prometheus can grow a little bit large, and one of the strategies that I also use is I employ Mayastor, so distributed distributed block storage locally to manage the Prometheus PVC. One of the big problems with using host path is there's no restriction on the amount of disk space it uses. So I've actually bound this to a 5 gig storage class, and a PVC under the Mayastor storage class. And if you want, you can highly replicate that. Again, with Mikrotik, you get a 1 and a 3 replica option, but you can just edit this and make it your own. You can change the replica count. And out of the box, again, you see you've got NVMe OF being leveraged, which is really, really cool. So I've described kind of my development environment, and I've shown you very quickly sort of the idea around setting up a Mikrotik cluster. You then wrap that cluster with a Mikrotik so that it has this level of persistence when it reboots. And then I've also described kind of how I use it with Tailscale and some of the things that I find really, really interesting there. In terms of the actual workloads that I'm deploying and why is it useful to do this locally versus remotely, well, I suppose the big thing is the turnaround time, right? I can push via a local registry. So I have a registry, like a Harbor registry as well for charts and for OCI. And I can put that locally and then push to that. So the latency and the travel time is much less, and I can see things very quickly. I can also, and I'll show you this now, which is probably more useful, is I can connect directly to that cluster, right? So when I'm building an operator and I want to go to my, say, open feature operator, which is, as I mentioned, one of the projects I'm working in, is that then connects against the local cluster directly, which is really nice. I can also inject and delete CRDs. And this isn't a production environment. I'm not working with other people here. I've got this completely discrete environment where I can get things going. And that's really, really nice. Again, this is one of those things where, you can see here that I'm trying to run it where I don't have certificates attached just because I've got webhooks. But again, it's not a big deal to me. I can just do a make deploy locally from my terminal here. And there we go. And now that's reflecting the change inside of my cluster, which is really cool. And there we go. So I hope this has been useful. If you are interested, there is a bill of materials in how to build your own Raspberry Pi based Kubernetes cluster with Mikrotik. I think it's definitely worth checking out because you might find that there would be a single board implementation that's enough just for you to run as a standalone node. It has a lot of improvements over running on your laptop in terms of having it persistent. You can start to think about it being a pre-production or a development-like environment that doesn't close with your laptop, and that enables you to see a bunch of stuff like long-term saturation, memory usage, CPU usage over time. It also lets you start to combine your applications and workloads, or even as a DevOps SRE engineer, you can start to play with running a cluster with no implications, but you can toy around with, as I said, pulling out the Ethernet cable, looking at changing the operating system. A very real thing that you need to do in production environments is how do you upgrade a cluster? How do you upgrade an operating system underneath a cluster? I've showed you that my management tool is super simple, right? I just use Ansible to run commands remotely, but you could build that out, right? You could build out Ansible playbooks. You could start to think about using Terraform as well with a local provisioner, and there's a whole bunch of different ways you could expand this cluster. You could even run multi-cluster under the same switch, or you could look at running a couple of different switches and clusters talking via a gateway. And this can start to set your creativity on fire and to think about other ways that you might want to test and develop applications offline. So thank you again for joining. I hope this was useful. Please do like and subscribe if you like these videos. Leave comments, ask questions. Super happy to answer. Again, this isn't a panacea. This is just my development environment, but I do hope this gives you a glimpse into the way that I work when I'm building out Kubernetes operators and code, or I'm working against cluster resiliency and other parts. Thank you so much. Goodbye.